Right. Well, here we've got a solution for a sort of differentiation integration problem. This is taken from a CIE paper, and this kind of problem is sort of fairly typical in that particular specification. Right. So we've got a differentiation to do. And hence find this integral. Well, as with all these things, when it says hence, then obviously it's linked to the first part. And if it says hence or otherwise, it still means it's linked to the first part. So anyway, let's have a look at this. It's given that y equals this function here. This is it's a product, but also we've got the chain rule involved here. So let's find that derivative. Okay, so the main thing we're going to use here is the product rule. So we're also going to use the chain rule in this. Just to remind ourselves, the derivative of a product of two functions, f and g, is equal to the derivative of the first times the second plus the first times the derivative of the second. You sometimes see that written the other way around. I kind of like it like this because it sort of looks a little bit more like the quotient rule, so it makes it easier to remember. Okay, so if we then just take that through, well, the derivative of the first function is derivative of that. Okay, so there's going to be 3x to the power plus 1 to the power of 1. Two of those. That's 2 as a result of multiplying by the exponent. But also we've got the derivative of the inside function, which is 3. So this basically, oops, including 3, is f dash in this case. And then times the second function, which we're not touching in this first term. And then the second part of this is going to be um, the this function, x plus 1 squared, times the derivative of this one. Well, the derivative of natural log of x is 1 over x. So basically, we've got 1 over 3x plus 1, and then we multiply by the derivative of the inside function, again, the chain rule coming into operation, and that is that 3 there. Okay, so and now we've got some cancellation going on here, which is good, and that's going to leave us with this derivative here. Okay, so that is part A. Hence, find this integral, which looks a bit more difficult. I'm guessing we can use the chain, the product rule for integration there. I've not actually tried it, but we don't really want to use that. And anyway, we're going to use the solution to part A. So if we look at part A, what we've actually done is this. We've got the derivative of that is equal to that. Yep, it's fine. This is the derivative operator. We're kind of taking y out of the thing. Um, so the derivative of that equals that. That's what we established in part A. Now, if we integrate both sides with respect to x, then what we're doing is we're taking the integral of this side, or the integral of a derivative. So basically, that's just that function, isn't it? So that's that. And then equal the derivative of the right-hand side. If we split that up, then that's going to be 6 times the derivative of that plus the three times the derivative of that, essentially. Right. Okay. So what this has done is it has, look at this here, this bit here. That is what we're being asked for. Right, so that basically is the trick. Now we just have to reorganize this. So if we subtract this term from both sides, then and divide through by 6 by this 6 here, we're going to get that the integral that we're looking for is going to be equal to this long. Now the point here, of course, is this. This is a fairly easy power rule integration, and so that works through nice and easily. And yeah, we just so if we do that integral and through divide 3 by 6, we're going to get that. So that is the answer. So that integral is actually this, and we've sort of leveraged part A. Now, we see this quite a lot, and if you see a question which has got, a derivative, hence find an integral, then there's a pretty good chance it's going to be a problem of this form. Now, very often we may not get this term at all. Um, but if we do, the likely thing is that it's a relatively easy integral to perform, which it is here. Okay, so that is basically it. I mean, I suppose there's another form where you could actually get something which is very close to this. So when we reorganize, we get something which is kind of fairly easy to work through. But there we go. So hopefully that has been useful. So thanks for listening.